Hello everyone, welcome to the lecture series 6 on the topic Foundations of Algebraic Structures and Number Theory. So in this discussion, I would like to make you travel in the applications of mathematics in the modern world. For example, I'm willing to talk something on machine learning. So applications of machine learning. In the previous discussions, we are talking more on theoretical areas. So what is a group, what is a ring, and how it is connected with the algebraic structures of real-time applications. So in this discussion, I would like you to make you understand some applications of machine learning, so where mathematics is involved. For example, you can take any kind of algorithm in machine learning. So each and every algorithm in machine learning is connected with mathematics. So for example, mathematical foundations for machine learning is very important. In this plays the concept of groups and numbers and rings and various things of algebra. The fundamental, I could say, like a fundamental framework for machine learning. So I could say, like in algebra, for example, in linear algebra, in many things, like in school level, we would have discussed about matrices, mappings, functions, and various types of functions. These are forming the backbone of many machine learning models. So understanding these concepts will really help you grasp how data is manipulated, how it is transformed. So data plays the vital role. Data analysis is what you're doing, and lot of filtrations, lot of transformations. So and its conclusions and its future perspectives, all these are involving mathematics. So mathematical foundations of machine learning. While talking about mathematical foundations, there are various things like linear algebra, probability and statistics, optimization and optimization techniques. So there are various things available here. So you might wonder, so we were talking about foundations of algebraic structures. Now why we are going into various things? So in order to make you understand, like in order to make you give you a clarity, like not only algebra, there are some more ideas in mathematics like probability and statistics, like various optimization techniques related mathematical concepts. Again, it plays a wonderful role in machine learning. So I'm trying to give you a diverse nature, I'm trying to make you understand, like algebra plays a fundamental role with which it interconnects various things into it. Okay, not only algebra, along with algebra, algebraic structures, it's trying to connect with other disciplines of, I think you know about probability, you know about statistics and various things. Okay, so these are playing again a wonderful role in connecting with these things. Okay, so in this discussion, what I was trying to talk with you is, so mathematical foundations are very important to start a career, to start a discussion, to model a machine learning structure. So not only algebra, not only algebraic structures, so there are various other connected domains. So if you are good enough, if you are able to incorporate all those structures together, sure, there is a very important benefit of understanding the algebraic algorithms. Because if you're going to work on an machine learning program, okay, you are given a task, you have a case study, you have a real-time problem, you want to make an algorithm to it. So how you're going to do? So suppose if you take algebra, so how can I connect algebra with machine learning? So what are the different types of algorithms that are connecting with machine learning? For example, you can say like matrices, or you can say different types of spaces, because it's just to think and see. Data set, data structures, all those things are occupying space, all connected to each other, and they form a cluster of content. So in order to work on that, in order to filter that, in order to according to the requirement of the user working on that, all those things, it requires algebra, where algebra works on operations like addition, multiplication, subtraction, and you can see matrices. You can see so how the matrices are interconnected, so how the transformations are happening, so what kind of transformation is, what is a linear transformation, and even you can think more on like how the transformations are happening. So what about the functions connected to this? So what is a function first of all, and you call it as a bijective function, you call it as a surjective function, like various functions you say. And algebra, again you have homomorphism, homeomorphism, and isomorphism. So what are they, whether they have some connections with machine learning. So like kind you can think more on this. Again, if you talk about other, it's interconnected domain, maybe probability and statistics. Okay, this machine learning offer deals with uncertainty and the noisy data. So probability helps us to model this uncertainty. So while statistics provides a lot of statistical tools to analyze in order to interpret, so like kind. So optimization techniques, maybe machine learning algorithms aim to find the best solution from a set of possible opportunities. Okay, so I'm making a thought process to you, I'm trying to drive you, I want you to think on this. So how these kind of mathematical foundations can be helpful to you in working with machine learning. Machine learning is nothing but you're working with the data connected algorithms. Okay, so thank you for listening. Thank you for listening this lecture. We will proceed further on the coming lectures.